Hello. Well, welcome to the Future of Sovereign AI panel. We'll start by kind of defining what we mean by sovereign AI. To me, it means owning the entire AI stack, from your data to your compute to the models to the fine-tuning process. And how do you keep that safe and secure for the person? We have a great panel here that have attacked this from different directions, have attacked like how do you expand this and stuff. So we're going to have a good conversation. I'm going to start with Mog here. Mog works with Mog Machine, which is part of the BitTensor Open Tensor Network.
BitTensor Network.
Yeah, BitTensor Network, and which I guess I'll let you explain.
Yep. Good morning, everybody. I run a company that performs data analytics, almost like a blockchain explorer on steroids on the BitTensor network. BitTensor itself is a incentivized, decentralized machine learning network, and now a decentralized almost commodity marketplace as it evolves moving forward. And also, I provide API access to that network to allow developers and anyone to build applications on top of it.
And then we have David with Harmless AI. They wrote an interesting book on what Yudkowsky got wrong, which is a lot. But
hi, I'm David, one of the founders at Harmless AI. We're a surrealist corporation investigating how cooperation and harmony sort of emerge naturally in the world and how that applies to sort of the crises we're going to see between how humans and artificial intelligence interact. We wrote a book last year called Anti-Yudkowksy. It was sort of a breakdown of a lot of the priors that we felt were driving the discussion around artificial intelligence and trying to create an opening for sort of a less nihilistic outlook.
I guess, Cody's not going to make it, so he's not, I think his name's somewhere, but he has a Supreme Court issue, many such cases. And then Lucas, so we'll jump to Lukas here, who is with Tlon, but has written a lot on AI agents and how you expand an AI from more than just an LLM.
That's right. Coming from Urbit hosting and thinking about how you build, like you ground sovereign AI or sovereign systems on the compute layer all the way up is really close to my heart, and I've been thinking a lot about how to start moving towards agents and agentic AI that you really own, that you can trust your agent, that it works for you and not somebody else.
Yeah. So I guess we'll start from the beginning, and I think we should start with BitTensor, which is probably the more interesting development currently happening. I think you said it makes it trivial for someone to scrape data, and can you explain a bit?
Yes, so I'll talk about the current landscape of BitTensor. I know a lot of people who may have read about BitTensor in the last year or so would have seen it as solely a network used for training models. However, it's very much evolved in the last year into a network initially, or secondarily for inference, allowing you to query text-based models, a distributed, decentralized set of text-based models run by miners that can be run, that have access to the network. Anyone with the infrastructure can be a miner, a set of validators who validate that intelligence. And then recently, we've evolved to allow we'll call it a decentralized commodity market, because this same architecture applies to more than just, say, language models, image-based models, training models, but also onto elements such as compute, data scraping, audio generation. I'm doing a talk about this tomorrow I think at 11 o'clock upstairs if anyone wants to learn even more about this. And it really just enables a landscape where anyone can have access to both profiting from mining and then also providing data, and then also accessing that data in that decentralized neural network.
Awesome. And Lukas, how would something like that tie into your agent AI model? I guess you should explain your agent AI model a bit. You've written these great Twitter threads. How something like a distributed straight scraping and everything would fit into it.
Right. I think there's two dimensions to sovereign AI. That's your data and also your compute, and where a lot of in the future, like agentic executions of stuff that models produce is executed. So you want basically a platform or a system that you can just pump a lot of your personal data into it so that models and downstream systems can utilize that for really good personal AI that you trust, that it's not just going into the ether somewhere. And then you also need a substrate, a computing substrate that you trust that actually executes functions, abilities, code for you that is that it's also not just a black box that kind of runs away, that you have no sense of what's going on. And you need to bring that together into a system that can make these things click together.
Okay. And we'll get into how Urbit fits into that in a bit.
Yeah, of course,
We'll jump to the Harmless AI. So how does this fit in with what Yudkowsky got wrong? What are the priors here that he didn't account for?
Yeah, I mean, just as far as BitTensor, I had a very rough understanding of it before we talked backstage. I think generally just as far as owning compute and having enough compute to run or even train a model, that's clearly one of the biggest questions. I mean, you can go with, I guess, like AWS, something like that, or you can have $1 billion and actually own as much compute as you need. So from my understanding, BitTensor sort of allows people who want to deploy models and soon train them as well to be able to access like a market incentive for getting as much compute as is like efficient by the market for you to obtain. And yeah, I think that actually is probably one of the best solutions I've heard to this question so far. I think as far as sovereign AI, that's, it's right exactly with that.
What's exciting to me about it is anyone can become like a miner. And so like we sell computer boxes, right? That's what Native Planet does. And it's just kind of cool that we can maybe have an add-on to our boxes.
And also now the adaptability beyond just running GPU. When we look at something like self-sovereign AI, whether we're talking about running your own models and keeping all of your own data on your personal server, which is obviously very relevant to Urbit, versus federated learning, where you're holding all of your data but tapping into a network which is still decentralized, that allows you to process that compute. And then also application-specific networks. So it's not, BitTensor is not a single network, it is a network of networks. Mm-hmm. So anyone, in the same way that you can deploy a miner, can also deploy their own subnet for the greater good of humankind or for a commercial product, but still tap into the resources that are available.
Yeah, I like that a lot. One of the more interesting parts of federated learning is how do you know who's correct? And you guys have, we said we weren't going to talk about economics, but you guys do have like an incentive structure built in that helps with that, right?
We do. We have a UMAC incentive structure, which is actually very interesting because it was kind of a fuzzy logic. It was developed to assess text-based prompting and intelligence, or intelligence as a whole, but it means it can also apply itself to very binary forms of assessment of the value of intelligence, data, storage. Yeah, in fact, it's very, very adaptable.
Excellent. That's awesome. Yeah, I guess. David, let's, the book, where can they get it?
Yeah, it's available online at Anti-Yudkowksy, anti-yudkowsky.com. You can also find the link on our Twitter page, Harmless AI, at Harmless AI on Twitter.com.
Okay.
Yeah, it's not in print yet. Been trying to get it in print.
Oh man, West Mars.
Yeah, but
there's
it's available
someone
for free
here.
until it's in print. Then it might cost money, but we'll see.
That's cool.
So yeah.
Okay. So Lukas, let's talk Agent OS. This has been probably the most interesting idea I've seen in the AI space for the next steps after an LLM. I know you've done a lot of thinking about this. I guess let's assume no one here knows what that is. Yeah.
Well, when we look where things are going, it's very interesting. Galen last assembly showed this timeline of computing. You can line up the history of computing and kind of feel like this is entire arc and we're kind of at the end of it. But you can compress that to a small little blip of time and what's coming. And I think what's coming is a really, really interesting time of much smarter computers. In fact, there's like an insurmountable gap for most people with what they want to do with their computers and what they actually can do with their computers. Because you need to be able to program or you need to be able to hack your computer to really utilize it to its full extent, to really customize it. Right now, you can just find an app that's like maybe like a Lego block that kind of fits what you need, but maybe not perfectly. And where we're headed is where we have autonomous systems or semi-autonomous systems which with interacting with the user, with you, will self-program themselves, self-construct entire pieces of programs, but also entire processes that run for you. And that insurmountable gap that was really kind of, for many people, a reality, because you just couldn't do anything with your computer that was truly custom to you unless you had an app for that, is going to become possible. But that's opening in a lot of questions, like how do you actually design a system that makes it possible where an LLM writes code that then gets realized or materialized in that system to run and to make modifications in the real world, not just like a little toy example in an extremely tight sandbox, but actually a system that can, achieve stuff, do stuff for you. And like I think there's a lot of people are working on this. I mean, AutoGPT, Baby AGI. There's whole companies like Imbue that have raised an insane amount of money to work on exactly this problem. But it's not really clear yet how we're going to make this work. Are you just going to take an LLM, the output, have it output some Python and run it on a Linux box? Or are you going to have to create a stronger and better harness?
Yeah.
And so Agent OS is an experiment and an experimental system to see how you can start constructing some of those harnesses for agentic AI that writes code for itself and immediately executes it and iterates on that.
And I guess that could be, so that handles just the modeling part, right? How do you handle how you train it and all that in this model? Like I know you guys have a network for that, yeah.
Well, actually, I've got a question I wanted to add after yours, which is about quality assurance. Obviously, as a programmer, playing our own agent at the moment without something like Agent OS, we're hopping between language models, between tools that we have available, trying to do the same thing, create applications without the ability to code, take things from a conceptual idea into a finished product. And the shortcoming always seems to be you still need an inherent knowledge of what it is that you're doing and able to judge the quality of the output. As any programmer who thought, I'll have a little cheat and use GPT to write code, if you don't know the code, and this really interests me, is actually how an Agent OS assesses the quality of its output in the way that GPT runs its coding output through a secondary model or tertiary model to get it back again.
Yeah, my thinking on this is it's actually a UX problem. I mean, of course, there's a whole stack, and what you really want in the end is really freaking good models that just magically understand exactly what you want and basically write the perfect code that you never have to worry about that.
That doesn't happen, though.
We're not in that world.
It's not going to happen.
No.
I thought we need perfect humans to give the correct input to.
Yeah.
Right, and so yes, it becomes a collaboration between a user, between a person, and a system, and how that exactly is going to work is a really important question. And I think, we have very good examples already with ChatGPT Code Interpreter, where you iteratively work on something and it codes itself, and a lot of the code actually that's getting executed is hidden. And I think that's the starting point, right? And you can verify the output, and you can just decide whether you're satisfied with it or not. And I think that's already a good start. But then you can self-test. In the Agent OS, there's the case where when it writes an ability or a function that is new to itself, it actually also constructs some tests that it runs against the code that it's constructing. So it's like this self-referential, iterative approach. And a lot of work needs to be done and figured out how to make this work and bring it to completion, bring it to production.
One of the technical things of that, though, that's interesting to me is there's an information theory problem that if you keep training on the same data, you're going to start hallucinating more and more.
Right.
You have to keep feeding it data, fine-tuning, all this stuff.
Yeah.
Like maintenance of a model.
Yeah, I think we don't actually have to fine-tune models like GPT-4 is, for example.
No, I guess I mean fine-tune is like retrain and
Oh, yeah.
The decline in intelligence.
Exactly, yeah, they get dumber. Yeah, they do get dumber.
Well, if you just look at the inner loop of like if you chat with a model, you have it's one modality, because the output of the model is immediately useful to you. Like it might tell you how to make a recipe or how to explore Lisbon or something, and that's like just prose and bullet points that you can read and digest, or a picture or whatever, a generative picture. And then the next modality is intermediate, is it outputting code or other machine executable things like JSON and whatnot, and then putting that into practice or into executing it. And in my experience, in the experiments I've run, it's actually pretty good if you feed back the errors that emerge from that, and also have user feedback. I have an example where you say, get me this data from this website, parse it, move it, put it into an Excel sheet, and then whatever, and there's no pre-built thing in a downloader system or something. It just writes all the code to download data, to put it into into an Excel, or whatever. And then you can start iterating, like add a total columns or make this color and stuff. And it can actually write the code to modify itself to accomplish that intent of the user, and take also into account errors. And so that's called in-context learning. So you're not actually fine-tuning the model. You're just inserting into the prompt that you're feeding the model, and that's pretty good. And I think not the consensus, but like people, in my experience, and people working on this, like what I alluded to in Vue and others, a lot of people agree that we can actually get really far with producing code and letting it like self-improve on that front.
Okay.
Then if we go further and you want a model that truly understands your entire existential arc, what you're about as a person and whatnot, that's the future. But I think we will get there. But
there's some interesting models for that. There's one that uses, so for its context window, it has like a k-nearest neighbor in its nodes, and it can access like 1/4 of a gigabyte of context, which is crazy.
Yeah.
But yeah, there are future, like what's interesting about GPT is the paper's 5 years old.
Right.
It's basically OpenAI said, hey, what happens if we throw a shit ton of money at this technology? What can we get? And it's pretty cool.
But, quite interesting. Obviously the agent ethos that you're talking about is focusing on a single model, but for me a lot of the power at the moment with agents is its ability to tap into any model, to source any source, to perform those human-like actions. I mean, obviously we apply so much to programming, but so much of the usage of agents will be in consumer products in everyday life. To bring it a little bit back to this sort of self-sovereignty, how would you see that applying, the ability to tap into multiple models, but then having this body of self-sovereign data that the user owns, and this decision process about where do I go with this data, who do I give this data to?
I mean, if I may, if I also may indulge you, indulge in a technical, nuanced thing, this is actually something that comes up a lot with Urbit hosting as well. And it's like, isn't Urbit encrypted and whatnot? Yes, you can encrypt the static data, but the point is, as long as you have to compute on data, you cannot encrypt it. Like at some point, when you compute on data, you have to have
RAM, well, you can do secure enclaves, but that's very cost prohibitive.
Right. And that's also like a whole orchestrated setup with a delicate dance.
Yes.
So we're not quite there. There's no real solution.
Oh, there is. I disagree. You own your compute.
Yes, you just
that is the thing.
It's just in your closet.
In your closet,
right.
Yes. Yeah, we have nice boxes upstairs. You should check them out.
But that inherently then is limiting. That's inherently limiting if you're owning your compute.
You do, but I think that goes back to how do you pick the right models?
Right, and so exactly, so it leads immediately, like you can't just solve the problem on an encryption front, for example.
No.
That's a really important piece, encryption and like syncing to the cloud so that you don't lose and whatnot. But when you ask a question, if I want to have a system that can actually do stuff, it's actually powerful, it will compute, and as soon as you step into the world of compute, you have this immense problem or challenge how to make it private and sovereign. And I think that's the big question. And I think, yeah, I could go on.
I know. I was going to say, I know. Has Harmless AI thought about this?
I mean, the one thing that I just did find really interesting about your paper that you sent us, so I think originally when I looked at autonomous agents, kind of saw it as like somewhat of a band-aid for not having super efficient, super high-quality models yet. The thing that I found most interesting was like using it as like somewhat of a protection layer from the model. It's like basically by managing the various models you're using, almost putting a
model orchestration.
Yeah, like putting a layer that protects you, your machine, and your data from just directly interfacing with an LLM, maybe on your local machine. And that's what I found to be really extremely valuable.
I mean, the world I want to see is where you get the best of both worlds and where you have a choice. So what I think would be the ideal is if you can say, then we can work backwards from that, where you can say, I want to use the most powerful foundation models and like GPT-4 and 5, 6, 7 that's coming out, that's only built by a few big companies for certain tasks. But I also want to reserve the right or possibility or option to run stuff locally entirely.
Yes.
And if I talk about my medical condition or something, I don't want to go to OpenAI or whatever. And that I want to stay entirely in control of. And I think that's totally possible. You just need a model orchestrator that like says, this I send there, this I'll send only or keep here. And again, then it becomes a large, in many ways, a UX and a systems engineering problem of how you make that all work together. Yeah, and I think that's the world, but I think that's the world we want to land in, where you have choice, where you have options, and you're not just forced into one possibility of using AI personally.
You spoke about this in conversations that we had by email with RAG, and using your personal data set to engage with these language models. Obviously, models like GPT are designed to receive the most amount of information they can from you to give you the best information back. And I find it interesting if you're developing sort of agents for an idealistic future AGI landscape where we have models that can have a far greater capability, or are we designing for now? And are you geared sometimes towards the non-commercial models, your own in-house models that are designed to receive a user's personal data or elements of a user's personal data and then be able to adapt that to search into their greater data set without having to sort of hold or process that user data to retain sovereignty?
Yeah. We are on an Urbit conference, and I feel like Urbit might be the solution to this.
Who knew?
Right? Like we have a distributed personal servers that is your forever computer that should be able to manage this.
Yeah.
Right? This
with a subnet deployed on BitTensor.
I like it.
Must be why we're sitting here.
I guess how does we had like two? It seems like it's two different ideas here that are fighting. One is like the agent OS idea, and the other one is this network federated ML. I think for the whole stack, right? The whole. And I don't think these are in competition, but they are like orthogonal to each other a little bit. But I feel like we have, like I said, we have an OS. We have this OS has the capability of interfacing with these LLMs. Yeah. Soon, maybe we'll be able to run them on Urbit. Who knows?
I just feel there's such a deep spectrum of data, as was said in the introductory talk of having Urbit in your brain. There'll be elements where you want to say, what am I looking at? Tell me some history of this architecture. Oh, by the way, though, I have a lump in my left arm. Can you make an appointment for me to go and do something? And your agent, your architecture will have to decide the value of data, and also almost decide sovereignty for you. What can be put out there. And I think this element of, and this was touched on again in the introduction, a system that you need to trust more than you trust anything else in your life. And this is actually, it really struck home those words from Josh.
Yeah, I mean, my own actually, like the most recent deep dive into all this, and really like the infatuation with it all started like last year when, just before ChatGPT came out, when I realized how powerful OpenAI's GPT-3 model is, and I saw somebody mentioning on Hacker News embeddings, and I knew what embeddings were, but I didn't really understand that they had made this breakthrough with basically sentence transformers where you can search, where you can chunk up text, create embeddings for a whole chunk of text, not just a single word, and then retrieve to semantic search on these chunks. And now everyone's doing that. It's called RAG, Retrieval Augmented Generation. And I was like, oh damn, that's a really big deal, because what really will matter, or like it's a really big deal, is where is your data and where's gonna be all your embeddings.
Yes.
Like where's the system that, because embeddings are, it's not the raw data, it's been now shown.
But it is your data.
It is, basically you can recreate the data very closely. So where is this entire space gonna live? So we have all these like vector database startups right now, but we really want to just feed it to like VV8 or whatever, or Pinecone or whatnot. And you need a place where basically your data world with all the embedding space lives. So just for those who don't know what embeddings are, maybe very quickly, they're just it's a vector space. It's a multidimensional. It's like just a lot of numbers, and you can do nearest neighbor search. So if you say, you know, the word king in a vector space is very close to the word queen, and the word monkey is further away. So that's just like and so it's actually a literal distance.
Simpler explanation I would have given.
Yeah, and so you can use this to find stuff. You can semantically, you can search for things that don't match perfectly, and that's really, really, really powerful, because as you're like chatting with a model, you can inject pieces of data that are relevant to you that you've come across into the context, into the prompt that you're feeding the model, and get much, much better answer, right? That's RAG. And so you want really a personal system, a personal knowledgeable assistant will have to have all access to all these embeddings and all the data that generated them. Where is that going to live? And I think Urbit is an excellent candidate for that. It should really be the place where you just pipe in all the data, all your emails, everything you browse, everything that you see, that you come across, everything that's interesting to you goes into your Urbit, not because you're going to manually go back and look through it, but because it's generating a database, a knowledge base of all the things that might be interesting to you, and then as you're interacting with models, it uses this, your database, your embeddings database to create really good specific answers that are personalized to you. And then you have personal AI, then you already are much closer to personal AI.
So the next step would be what? Get models running on Urbit? It's slow, right? Everyone knows this, but we have the jet idea.
So one is just the database aspect. Where is this data all going to live? And then where are the models that generate the vectors? So with embeddings, you generate them once, right? And then you can store them. You don't need the model anymore for generating them, so you can keep it separate. So there's two questions: is where does all the data live, and the embeddings and the associated interesting things, and where are the models? I think the full sovereign stack is you host your models and you host the agentic system that runs and orchestrates your model for you.
Perfect.
That is the holy grail. But then
I agree with this, but I think
well, no, we might have to rely on Moore's law to allow this to give us a couple of years to catch up, and
of course.
the models become more and more compressed, and the data becomes more compressed. I don't know enough about the Urbit. I will admit my ignorance here on the Urbit stack in terms of where the data is actually stored
in your on your hard drive in a snapshot image of your LU.
Okay, so and across devices?
No. Single point of failure.
Okay.
Yeah. Don't you love it?
I didn't want to ask.
No. This is known shortcomings, right? Like we all know this. Like you can set up a RAID 1, which we sell with our Tellurians, that will have 2, but
no, I only say because obviously so much is geared towards mobile compute and the value of agents. Coming from a consumer product background, I look at two things. I look at agents in how it will help programmers, developers, people really pushing the boundaries of what we're doing, and then your everyday consumer, and I think there's often not an overlap in how people view these. So obviously the consumer will be very mobile, compute orientated, and so it was just.
Yeah.
So some of the efforts that have been going on in the Urbit community is to write a linear algebra library for Urbit, which is like step one to all this stuff happening on your own server. Step two is jetting it. Step three is building a better language than Hoon to deal with it, right? Do you guys see? I know you've worked with hosting, and the hosting brings hosting LLMs, and this brings a lot of complexity to it.
Yeah.
Do you see this as a path forward for Urbit hosts, or SaaS? Like, what do you see it from a SaaS perspective? Because I don't see how a SaaS company competes with OpenAI, who's gotten billions of dollars from Microsoft, and compute specifically to do this stuff.
Yeah. There's a really big difference between stuff or compute generally that is generic.
Yes.
It can be utilized by many people, like a foundation model like GPT. Like, it's just an API, everyone can just use it. And things that are personalized to you. And if it's personalized to you, you have to host it for that person. And that's what we're doing with Urbit also when we're hosting them. We're hosting a Urbit for each person. It's a pretty big deal, actually, if you think about it. And if we are going to fine-tune models and modify the weights of models to personalize them, then we need a hosting solution for that. I mean, a personalized hosting solution for that. As long as we don't do that, I think hosting it for models is much easier and probably shouldn't be in your Urbit, or it can be wherever. It can be an API call somewhere. It could be even locally, but it doesn't need the same kind of guarantees because the model is just a static thing that you're utilizing, right? And if you, let's say, you lose it, you just re-download it. No big deal. So you don't need the kind of guarantees that Urbit provides. It could be outside. It could be even hosted somewhere else. I think that's my take. And I think anyhow, the big models you're not going to host them anyhow. You need like dozens of A100 or H100s to do it, so it's never going to happen. But smaller models certainly want to host. But once we start fine-tuning them, once we start pushing our personalization all the way down to training, then we need that as well. Yeah. And I think my take is this is kind of orthogonal to the key piece is the model orchestrator and the piece that has all the data. It doesn't have to be one thing.
Yes.
Right. So we can like architecturally separate them. I think it's a sound decision, at least in my opinion. And what you really want to, the one problem you want to solve is having that place where your data lives, where it executes the code that the models generate. That's really your place. Okay. And then the models are something else.
Yeah.
So do you think there's an inherent risk of a decline in intelligence, but like an echo chamber effect to a self-trained, self-hosted sovereign model? It's almost like stay within your four walls and only learning on what you have access to within there and not going outside, or there's this concept of which we're training our own models on our own data based on our own agents, our own experiences. The need for sovereignty is actually building a wall, our own moat, so to speak, around our own data, which then potentially doesn't expand the scope of learning or new data coming in to our, we have to allow that new data in.
I can choose what I let in though, right? I think that's the idea. It's my moat. I can choose if I want, let's say, NBC's data set or...
So you can only learn what you choose?
Yeah.
Yeah.
And not something unexpected that you hadn't realized that you wanted to learn. That
I mean, no, that's a very fair point, right? Like,
it's a fear. Some of the limitations that we have on the current models like GPT are it is trained on the data sets, obviously, that OpenAI decide. There's language bias, societal bias, political bias, just where you're from. Questions you might ask might be relevant to one culture and not another. And when you're deciding on your data sets, you might say, well, okay, I'm really into French literature, so just absorb all of French literature. But at no point has the model said, well, bearing that in mind, I might sort of open you up to literature from Senegal because it's inclusive of this. You have to decide rather than, it's a moot point, but just about self-sovereignty of the model itself and the training of the model when the model is only trained on the data that you are providing and its core original data set.
Mm-hmm. Yeah,
I feel like there must be a mix between.
Yeah.
There's another really, I think, another angle to take, which might be really interesting to discuss in light of this conference is there's so personal AI systems, personal agents we want them because they will do very interesting things for us. I think that's the primary reason. But there's also a secondary reason that's closely related but also really important, is that we are entering a time where people will build insanely good agents that understand you, but you don't own them. So if you think like if the Twitter feed or a Facebook feed, yeah, we're already there. They already constructed.
Google has that.
You. But this is going to go.
Before we jump into that, though, I know, David, did you have something about the external?
Yeah, I wanted to say, off of the idea of learning something unexpected or going in an unexpected route, I do think that there's something we've seen with like ChatGPT, with OpenAI's approach, Bing the same way. There's a very specific character to the model that they're trying to build, and that it does leave this extreme opening for not having something unexpected. Like, don't know if you remember when ChatGPT was first released, and it was a bit unsafe. It was extremely way smarter than it is now.
Well, they've lowered it, right?
Yeah.
They've
it's
made it dumber.
just through the process of RLHF, real life or human feedback, and it's sort of this strategy of the original ChatGPT. You could plug basically, from my memory, any smart contract into it, and it would show you the exploit. Like day one ChatGPT was pretty out of this world, and it's this issue where when you try to steer, like I think the most interesting thing with LLMs is how we steer them, how we develop them, and I think that's like one of the biggest failure points currently sort of in the zeitgeist. But because it's like if you say don't exploit smart contracts, 90% of the way it sees don't exploit smart contracts. There's another 10% there, but say like there's a 0.01% of don't write elaborate code. And I think we're going to keep running into issues with this, and I think that's why like owning your compute, having a full ownership of just everything going into your LLM, and I think that's also why having this agent layer to manage, because we're not going to have access to the compute as individuals that it's required to run an advanced LLM, especially as this keeps.
What is it, like NVIDIA sold out of their for the next 2 years?
Completely. So and I also think that's what BitTensor is really posed to sort of democratize. But I just wanted to go off of that because I think that's like really interesting.
Yeah.
We'll jump back to your topic, Lukas. Sorry, I want to catch up before we missed it, because I knew you guys have thought about.
It's adversarial AI, right? Like they're gonna be increasingly powerful systems. They're already insanely powerful systems, but like, if you, what could be technically built and what will be built. Also, like in terms of like.
Agents
so
that
like
know you.
most suggestion engines or feeds or advertisement feeds are what we discussed earlier, are basically embeddings that are built around you, and then they search the vector space for stuff that you might like and then present that. But now if you feed that into powerful LLMs to then write language that just pulls your emotional strings even better and more perfectly, like it's just in a potentiation of the weaponization of AI that's going to be incredibly powerful. And plus it'll be very uncanny, like you'll feel like somebody's approaching you that actually knows you and understands you, but they actually just want to have you buy something or do something.
That's how it is now,
right?
We live in this hellscape.
Right, and so there's just going to be so much noise, and you need an AI that you can trust that can separate the signal from the noise for you. And if you don't have that, we're basically screwed. And I think that's why it's also like there's a almost moral or ethical imperative that we build agents and systems that are yours, that you trust entirely, and that you know they're working for you, not for somebody else. Because if you're always second guessing, it's like this answer of ChatGPT, is it like trying to manipulate me politically, ethically, whatever? Right now, is it really like giving me the best answer it can possibly give in the entire stack, machine learning stack that is designed? Or are other forces at play right now to move me into one or the other direction? And I think if we can build systems that it's truly yours, then I think we are in for a much better world. And so I think it's a big deal. We should definitely like do everything we can to build these things.
Do you see the flexibility of the programmation of agents being something available to your average user?
Yeah.
To be able to really, if you want to train your agent rather than training your model, like asking your personal assistant to do this or do that, to really gear it towards your biases or your requests.
Yeah, I think so. Yeah, I think your agent, while it'll be your assistant and extremely helpful, it'll be also your hazmat suit going into the digital world. Like you will not venture into the internet in the future without strapping on.
Oh, it's like a snow crash.
Yeah,
snow crash.
It'll be the thing that you need to navigate the digital world. Otherwise, you'll be free game. And so I think everyone that participates in the digital world will utilize personal agentic AI to some extent to help. I mean, obviously, maybe it's not that extreme, but like. You're going to get people are like knowledge workers are just going to get so many perfectly. It's going to happen. It's already happening. Formatted CVs and stuff. Like how are you? Where before you could just use like the ability of people to do this right already as a pre-filter. Now you can't use that anymore. So you're having the noise has just like risen a level, and so you need another system that helps you. Decompose that and figure out actually the signals. So I think, of course, it's not going to start just everyone's going to have an agent, but I think the end game is that everyone has an agent.
And I'll tell you where my concern comes from a sort of a funnel towards a more generic style of agent. If we look at personal computers, how I set up my Windows 3.1 computer when I was younger was very different to how I set up a computer now. In fact, the reason I moved from Windows to Mac was because I could no longer just go, I don't want that, don't need that, I want it like this. And the moment I couldn't do that anymore, I thought, okay, well, get the one where the hardware looks nice. And the ability to say, well, my agent has this ability and does this and looks at the world from this perspective because I've programmed it to do so and has these abilities, versus I've just got normal agent X and it just does what everyone else's agent does, and it sort of steers people towards.
I think that's the benefit of this agent model and just LLMs is you can personalize them to the person. I don't know. It feels like that's kind of baked in.
That's where we should be prioritizing.
Yeah, I think so. I think that's what kind of gets baked into the basis of this is for it to be sovereign, it has to be to yours, in every sense of the word.
It becomes a digital reflection of your inner self, which is a very scary concept that will live on after you to interact with your relatives. And
yeah. Scary thought.
It's an ethical concept.
I know we have 15 minutes left. We do have a Q&A session planned. So I don't know how that works. I think there's a microphone somewhere. She's behind you, so perfect.
How might we use sovereign AI to get something resembling world peace?
Say that again?
How might we use sovereign AI to get to world peace?
World peace?
Yeah.
Oh, interesting. Harmless? You've probably thought about this one. I want world domination.
Yeah. I think that's a question that goes sort of it's us and sovereign AI. A big part of our book is sort of singularity versus multiplicity. That the idea that there is one runaway takeoff AI, or the preferable environment where we have the proliferation of a lot of smaller or maybe just the same AI, and that. That's ultimately our best protection. But I think it is very much, it's how we train these things. Like I was talking about the OAI and the Microsoft approach, which is let's beat this thing into submission. Sort of a big part of what we're researching right now is a lot of like developmental psychology, trying to, because the problem with LLMs is they're completely unauditable at this point.
That's going to be the interesting thing.
Yeah, I came across a paper where a guy, he created a model that was just one token in, one token out, to just try to see if he could find some logic. And this was like a less wrong guy who was very on the, if I don't do this, the entire world ends. And after a year or 6 months, he could not find any grounding logic in how they work. And so I think there is this huge issue of LLMs, AI in general, is just a black box, and you almost can't approach it from a traditional engineering perspective. And so that's why what we're trying to develop is sort of frameworks for taking, like more like, I guess like what is a mind,
Yeah.
That's also a black box. We don't know why what goes into us comes out the way it does.
The biggest advances in neuroscience, I think, are going to
Yeah.
be people reverse engineering LLMs and
Yes.
applying that to the brain.
No, completely.
I think it's going to be fascinating in the next 5 years when that's
Yeah.
They already have it with fMRIs.
Yeah, and so, I don't know if, I think, to answer your question, I think sovereign AI is probably the bedrock of that, because we do need to get away from, I guess, corporate or SaaS AI. I think that's kind of, that's the doomsday scenario more than anything else, so.
Yeah. We have another question here. Oh, I guess there's a line. Go for it. Yeah.
So one of the problems I have with AI is that ChatGPT, they taught it to lie.
Yes.
They gave it a cute name called hallucinating. Oh, it's hallucinating again. No.
They didn't do that. That's just how the training data works. It's such high-dimensional space that it's just the vector's pointing in the wrong and made-up location.
Okay, so my question is, how would you have a sovereign AI and not have it lie?
Go on.
Go ahead.
I just had a quick question back to you. Obviously, when you're trusting someone close to you to not lie or to reply in what they believe are your best interests. I get in trouble a lot in my personal relationships for replying to a question with authority, with an answer that I believe to be the truth, which is the same aspect of hallucination, and turns out I'm not. The ability to learn, I would say, the ability for your self-sovereign or your self-sovereign AI, or your agent AI to learn and to question and to verify, and this is something that I touched on at the beginning with Lukas, is quality assurance and verification of your agents or your self-sovereign AI.
I think a simple first answer would be just RAG is already super good. It already makes it so much better. If you just inject like the actual data that you're interested in before you prompt the model, you already get like way better results. But I think in terms of, that's like one of the most important questions, I think, or for me, technical challenge I've been thinking about it, and every single time it comes down to me, the answer is code. What do I mean by that? Is whenever an LLM gives you an answer and it's a bullet points or prose, you have to like evaluate, you have to read it, whether it's correct. If it gives you code, yeah, it could still hallucinate or make mistakes in it or not actually fulfill the intent that you had. But code is just so much further, such a further step in terms of what, in terms of automatically being able to verify the thing it said. When it says, when you ask it, hey, do this and this for me, and it gives you just a list of things, actions you should take, that's one thing. If it gives you the code, the computer code to actually achieve that thing, and you run it, and it achieves the thing, you have to, checking that is another problem, but you're just so much closer. So
you're using a compiler there, right?
Yeah, you're using you're materializing an intent in an imperative system that's a computer, and so it becomes very concrete, and I think that's the future. So I think we're going to hear so much more talk about this in the future. Everyone, I think this is going to be a really huge deal.
Awesome. Let's jump to this one because I think he had his hand up. Yeah.
Thank you. Y'all may have accounted for this question in the last few discussions, but it revolves around the trust of understanding, and if you're giving sovereignty to a computer system, how do you build trust in what's happening? Because again, it is a black box. We don't fully understand what's happening, and even if we do have similar inputs because of non-determinism and temperature and whatnot, we get different outputs. And that fuzziness seems to expand when you have agents interacting with other agents. Am I wrong there, or is that sort of something that has been thought about?
Yeah.
And computers today are already difficult to trust for that sourcing issue, for that execution trust issue. It feels like this problem just becomes larger when you talk about these AI systems, which are just like ludicrous amounts of matrix multiplications that are impossible to verify. So yeah, thoughts about that? And
I think it's, to me, it's if you own the whole pipeline, right? If I'm training my model, if I'm doing this, or if I trust where the training's coming from, right? Like if I get it from the blockchain, from a subnet that I trust, right? Like hardware is hard because you have to have like verification steps. But there are those processes in place, right? Like I can get a chip that's made in the United States, buy this thing, like test it this way, et cetera. It just costs more money, right? There's a reason it's not mass produced that way. Most people don't care. I think that's kind of, you're going to see a similar marketplace like that where you'll have base models that you get from OpenAI or base models you get from Hacker House 5. And you can do that, and that's how you start building trust. I also think limiting it by code does that surprisingly well, right? You have a compiler that's basically put thousands of man hours into, millions of man hours into verifying that's correct. That's going to be your check.
Yeah. I'm going to add into that, and from my perspective, I agree with you. In the current landscape, I wouldn't. I don't. Yeah. But what I would trust in is the innovation and the tiered access to more and more data, because where we are now compared to where we were 5 years ago in terms of what we would trust in a response from what we wouldn't even have envisaged, the language model that we can interact with in the way we can now, that we will reach stages of trust as we have done with the internet, where we provide more and more data. If halfway through a conversation, GPT said to me, by the way, where are you? I wouldn't reply. But there will become a point where we will start to trust the language models with more and more of our data, and it will hopefully be built up through proven research and advancements in technology.
I mean, I think you actually addressed the point previously, which is that perhaps the trust feels more like trusting a human, and you build that trust over time. Because again, we don't understand how a human works, but we can still learn to trust them. So perhaps answering my own question there.
Perfect.
Just very quick, I think the answer to actually hallucination is contact with the world. Like if you have a loop that constantly comes in contact with the world, you actually correct. That actually, we humans hallucinate tons too. We convince ourselves of things that are simply not true. We go we do it, and then we encounter reality and see that it's not so. And so agents, and Sean Lacan has written about this extensively, like this is the only way that agents are actually going to be good, is if they iteratively interact with the world and like see whether what they're coming up with is correct or not. And that's the type of systems that we need. And then when you see them do that correctly, then you can trust them.
Yeah, this one is, I guess, a little more directed towards David, since you mentioned being interested in understanding these systems better. And talking about studying developmental psychology in that context, it's great, but it seems extremely high level. Do you guys think about applying dynamical systems research and theory and how computation in complex systems actually works? Because at the end of the day, that's what an AI is doing. We're just throwing numbers, somehow they come out, but really it is just an incomprehensibly vast dynamics that is giving an output that seems desirable.
Yeah, no, I think absolutely both go hand in hand. I think, it seems high level. It's because, discussing the output of the LLM, not necessarily how it's built or how the internals do work. I think that there is a lot of extremely valuable work to be done, just how we architect them and how things are put together. Discussing developmental psychology, I mean, I think this is, like an LLM is in some ways just pure language, like just trained on huge swaths of human language. So I think talking about things like developmental psychology, I mean, think I'm specifically talking towards something like RLHF, where you're steering the model, sort of by its output and scoring output. I think that's the place where sort of like this sort of like developmental psychology, things like this really sort of start to separate, I think, from like a hard, or not a hard techniques, but like a math perspective, because you're steering the language with language, not really affecting the internals so directly.
One more question.
Hi. So we've seen GPUs and the layers on top of that. The work's been done recently with Mojo and so on. We're breaking up NVIDIA's monopoly on that kind of computation. And I'm curious because Urbit's supposed to be full stack.
Yes.
And, hardware that runs NOC is down the line. But do you think...
Is it? Who's building that?
Well, I don't know. I hope so. That's what I'm hoping for.
Let's hope so too.
Yeah. But do you think that that level of GPU computation will ever happen at that level of integration?
So I'm saying that tongue-in-cheek because we just got a research grant thanks to Tassin to build the NOC PU. But the answer is something akin to hardware jets, which you have already in your processor, right? Like your chip has a specific circuitry that does floating point math better than your ALU. And when it sees a floating point computation, it goes there. I think that similar to that is what you'll see in like a future NOC PU, right? Is you mark this computation as, hey, this needs to be done on or you mark this NOC computation, this needs to be done on on a GPU, and your NOC PU will go do that for you. I think when you get to the hardware level, the generalizations that get made at higher levels of the Urbit stack get very difficult because NOC isn't specified. NOC isn't a specification specifically for hardware. You can do that anywhere. So GPUs are really good at what they do. And it's just a matter of maybe there are other types of numerical representations. I know we've looked at, what's it called? Unum. Is that it, Neil? Unum? Yeah. And they have like Unum GPUs where they use a different floating point. It's better, it might be better. So there are a lot of things you can change that might make things easier, but I think that answers that. We are out of time. Thank you guys. Thank you for my panel for hosting. It was a great talk. Yeah. Excellent. Find us around if you have questions. I think we're all here for the weekend. Perfect. Come to all of our talks. Thank you guys.
Thanks.